Good morning, everybody.
Good morning.
Today I'd like to speak to you on the environmental correlates of floristic composition in KZN. I've been warned
Just press the space button on the laptop to navigate. That's just for the laser. That's just for the laser.
Okay, so just to give you an overview of my talk, I just want to give you a background to the study, look at the aim, the methodology, some results, and then a discussion of the results. Okay, KZN is floristically a very diverse province. It forms part of the Maputo-Pondoland Albany biodiversity hotspot. We have over 6,000 vascular plant species in the province, and this diversity is a result of the high variation in soils, geology, topography, and climatic variables. We can see that there's a strong gradient just if we look at altitude. It goes from the coast to over 3,300 meters in the berg, and these steep gradients are very intense over a very short space of time, so it's the maximum amount of variation per unit area. So the aim of this study is to look at the environmental correlates of floristic composition in the province, and this is to help us with our conservation planning efforts, because if we understand the drivers of this floristic diversity and the patterns that are made, we are better able to plan for that to ensure representativity and persistence into the future. Okay, so I collated a whole lot of plant relevate data, and it's shown by the dots on the map of the province. I had 2,257 relevates that I landed up using. It represented over 2,400 plant species. It was restricted to grasslands, savannas, and the Indian Ocean coastal belt only. And despite having such a vast number of points, we can see that there are still gaps in the distribution. And this is due either to the high level of transformation we are experiencing within the province, or that people like to work in protected areas, and you can see the clumped nature of the points in the protected areas, or it's just plain downright inaccessible. So the data was cleaned. It was presence-absence data. I discarded only genus-level identifications. Subspecies were taken back to the species level. I discarded all species that only occurred once or twice in the entire data set, and also discarded any outliers in the data set. Okay, this is not a stats lesson, but I needed to use non-parametric statistics to do this analysis, and I used, for my ordination technique, non-metric multidimensional scaling. This gave me my plots in ordination space, to which I could then individually correlate the 54 environmental variables that were identified as being important for plant species distributions. I then used hierarchical cluster analysis to create groupings of those floristic plots, and then indicator species analysis to objectively identify where to prune the dendrogram. I used multi-response permutation procedures to test for statistical significance between those groupings. I then wrote those groupings into the environmental table, which then got fed into CART, which is classification and regression tree analysis, and that was used to identify the thresholds of the environmental variables. Once those thresholds were identified, I could then do the spatial mapping of the communities. So this rather chaotic looking ordination diagram actually does have some meaning. And on the first axis, it's very strongly correlated to different temperature variables. The second and third axes relate to moisture gradients, and then combinations such as plant available water and mean annual evaporation. We can also see that there's quite a strong outlying group for Maputo-land. Okay, just to look at some of the correlations, there's a very strong correlation to temperature on the first axis, and a rather mediocre correlation to precipitation, variables and their derivatives such as plant available water and mean annual evaporation. In the cluster analysis, we identified 23 significant community groups, and this was fed into the classification and regression tree analysis. And interestingly, the first division in CART was based on the number of frost days that occur in the province, and it happened to be around 21 days in the province. And from the CART analysis, we could actually identify 34 groupings of vegetation clusters. So the map on the left is my statistically derived CART communities, and the map on the right is actually our current vegetation map of KZN. Now what I did was I took the 56 vegetation types in the province and I downscaled them to match the 34 groups identified in CART. And then I just color-coded them so that we could compare them. And you can see that, broadly speaking, there's quite a strong correlation between the two maps that have been derived, although there are some discrepancies between the two products. So if we look down on the south coast, we can see that the CART analysis is suggesting that the south coast region is actually quite distinct from the rest of the coastal belt. And I find this interesting because in the original Messina and Rutherford vegetation map, that was pulled out separately, but in the newest vegetation map that they've come out with, it's actually, they've sunk it together into one, and I'm presenting here statistical evidence that there is floristic differences between the species from north to south, and one can expect that because there's an over 2 degree temperature range from the north to the south just along the coast. If we have a look up in the Maputo-land area, we can see quite a strong correlation on the vegetation types there, and that's despite soil and geology vegetation types not being important predictors and not being used, even though I had them as environmental variables. We can also see that the Eastern Valley Bushveld is coming out, and that's despite not actually having any releve points in that vegetation type and the Tugela Valley Bushveld. So it's just climatically so different that it's being pulled out in CART in any case. So from this we can derive that this technique is quite useful to be able to, at a broad scale, map vegetation communities, and we might even be able to use it to objectively identify some of the thresholds associated and used in the vegetation map that is fairly subjective. So moving on to the discussion, we could see that temperature has accounted for a lot of variation on the first axis and composition, and that mean annual temperature is a strong descriptive variable. We can also see that other temperature variables such as the maximum temperature in the hottest month or the coldest temperature, the coolest minimum temperature in the coolest month are actually really good predictors as well. So coming back to the frost duration, we know that frost is actually limited to savanna trees. So if climate change were to start happening, we can expect, as we have less amount of frost, we can expect savanna species to move into our grasslands. We can also expect to have an alteration in our soil nutrient cycling in soils that are used to being frozen in the higher berg areas, and experience a change in nutrient cycling as a result of the soils warming up. The secondary gradient identified was far more complex. It is a moisture gradient, but it includes other variables which combine aspects of temperature, moisture, and soil. So your plant available water and your mean annual evaporation. And the precipitation is more complex, and that's because of the topographic effects and the oceanic influences that we have. So it's just not as clear a gradient as temperature. And then again, moisture variables indicating stress periods are also important. And one could then, if one looks at the climate change predictions where they suggest that we would have a longer inter-rainfall event and a higher event on its own, if this were to coincide with a longer stress period from heat, we might expect greater changes in our vegetation to occur at those coinciding stress points. So climatic variables help to describe vegetation composition at a provincial scale, and soil characteristics, slope and aspects variables only became important at a local or a landscape scale. So the current determinants of floristic composition are climatic variables, but it's temperature and precipitation, but it's these exact variables that are predicted to change with climate. So we can expect our vegetation to change greatly, and therefore it's imperative for inclusion in our conservation planning initiatives. Thank you very much.
Thank you very much, Debbie. You gave us an allowance of our question time, 5 minutes. The audience gathered time for questions.
What is the resolution of your analysis? The cell size?
The climatic variables are 1 arc-minute, so I think that's about 1.4, 1.7 kilometers. So it's broad scale, but it's the finest data we have.
Yes, sir.
Debbie,